Hello, welcome. My name is Filip Coulianos. We are here in Stockholm, Sweden at a brand new studio called NetEaseGames, which is founded by me and a couple of my fantastic friends from way back. We're right now developing a brand new science fiction co-op adventure, which we're super excited about. But that's not what we're going to talk about today. Today, we're going to talk about my previous experience, which is called It Takes Two. And that project, I was working as a lead level designer, so it's from a game design perspective. We're gonna look at how me and the design team got together and produced the huge amounts of variety and all the mechanics that went into that game. So first, we're gonna look a little bit at a background, how It Takes Two came to be. Then I'm gonna have to talk a little bit about the technology behind the production, and at the very end of the presentation, we're going to have a look at a case study where I'm just going to go through the whole creative process of making a little part of the game from start to finish. All right, so where did it all start? So It Takes Two was developed by a studio here in Stockholm as well called Hazelight. It was founded about 8 years ago, and it was the first game that we made together there was called A Way Out. It was a cooperative experience that you play together, and it was also a game where what made that game kind of unique was the fact that we had we needed to be several players. It was a cooperative experience only, and when the game came out, people really liked that. It was something that they really appreciated, and it made the game stand out. So it became kind of a natural thing that for It Takes Two, we did. It kind of followed in the same vein. Now, when developing A Way Out, there were a lot of similarities there that we can identify at first. So A Way Out was multiplayer, meaning, since it's a co-op game, you have to play with your friend. We also had to support playing over the network, which was a huge part of the technical challenge there, which is the same for It Takes Two. On top of that, both games are always split screen. It was also kind of a linear story. You told a story about two convicts, trying to escape prison and to take out the revenge on the guy who put them there. So it's a very linear story, like a movie almost, and that's something that It Takes Two ended up doing as well. So both games were linear and telling the story from start to finish. And one thing that A Way Out also did was having a huge variety in mechanics. You don't really think about it, but that was actually a huge part of the game. And the reason why I bring this up is that when you look at it from a technical perspective, both A Way Out and It Takes Two has a lot of similarities from a technical perspective. And one thing that started when at the end of A Way Out, the programmers of the game realized that we had to do something. They couldn't really work as fast as they needed to be able to do all the mechanics in A Way Out. We had shooting sequences, we had car chases, we had a lot of unique mechanics that was only used for a single scene. And that on top of the fact that we, the design team, constantly changed what the game needed to be. We had, changing design direction, made it very difficult for them to work as fast as they could. So they started developing something new, which was called, they implemented something called AngelScript into the Unreal Engine 4. So Unreal Engine 4 was the same engine that we used for both A Way Out as well as It Takes Two. And they made this plugin for Unreal Engine 4 where you put AngelScript as sort of a super fast scripting layer in between C++ and the blueprints. And it was quite fascinating because, they could, AngelScript is something that you can write really fast code, and then as the game is running, you can basically change the lines of code and press save, and immediately the behavior will kind of propagate onto the screen, which is absolutely amazing. And it always worked, and I think that was one thing that kind of caught me and the design team's attention. Like, hey, this scripting language looks really interesting. And personally, I kind of come from a background of modding and indie game development, so I'm kind of a self-taught programmer. And I thought, hey, actually this AngelScript thing seems really interesting, not only for programmers, but for us designers as well, to prototype our own mechanics and stuff like that. So I thought, maybe it's something that other guys in the design team are interested in as well. And if not, at least I will use it. So, at the beginning of, development for It Takes Two, which was the next game, we sat down together with programmers, and they would show us the ropes, learn, a lot of us in the team, how to program and how to use their amazing tools. And we started really early on using AngelScript as kind of a part of our prototyping phase. And in the beginning of It Takes Two, before the game had taken form and we knew what the game was going to be, we just sat down and we tried a lot of mechanics back and forth, not really caring too much about the context. We just focused on what was fun from a cooperative experience. And then we would use AngelScript as a way to realize those ideas and a way for us to train and get used to the tools. And as we kind of, started molding and understanding what the game was going to be about, we starting to understand what was fun, and we had the story coming along with It Takes Two, we realized that we could actually, a lot of these systems that we started prototyping was something that we designers could keep ownership of throughout the whole thing. Usually, a designer maybe would do a small prototype and then a programmer would kind of get the rest of it and take over at some point. But we realized we didn't really have to do that. And I think that's a huge key, because that meant that the person who came up with the idea could realize the whole thing from idea to kind of a finished product. Another huge win was that the programmers who did all the gameplay used the same tools as the level design team, which was a huge win. The interesting part here is also that, yes, we were a level design team, but suddenly we were also kind of programming and designing at the same time. And the line between, level designer, game designer, whatever, became very blurred. We were all suddenly creative people, making stuff as we went along. And I think that was also a very good thing, because usually if everyone is given a very specific title, they tend to kind of get like some sort of imaginary bounds around. Like, okay, my title is animator, I'm not supposed to do anything outside of that. But having this kind of blurred lines between what you were supposed to not, it was more about kind of the end experience. So I think that was a huge win. So, but how did that all look like? If we kind of just take a case study from start to finish, how was AngelScript and how was the creative process of It Takes Two? It would always start with the storyboard first. So we would basically have a storyboard that would inform sort of the context of the entire game. It was kind of be very much focused on the story itself and not so much the mechanics or what's going to be a level, what's not going to be a level. It was more about the general kind of, this is what the story is about. And then we would sort of divide that into chapters. So at first, when I looked at this case study in Dinoland, it was part of Rose's room, which is a part of the game where the players hadn't really started mending, or the characters in the game hadn't started really mending their relationship yet. They were still kind of, confused about, this magical world they ended up in. And I think we would use, in the early levels of the game, would be to add mechanics inside the levels instead, so that it would just something on top of their regular moveset. So we looked at the storyboard. We knew that, okay, we're gonna make the Rose's room a playroom. What would be fun in playrooms? And we would throw out different themes, and one of them would of course be, toy dinosaurs. It's something very relatable. Everybody likes dinosaurs. And then we would start brainstorming around that. What would that be like? And one of the ideas that I remember floating around a lot was this long neck brontosaurus, because we knew from a story perspective also that there was going to be like a small toy train track throughout this whole toy room, and the players would kind of need to use that to progress throughout. And this track would then be blocked by different things that you would have to move away to be able to progress. And we thought, hey, wouldn't it be cool if this long-necked dinosaur would be able to kind of put the track together or remove pieces? And that's sort of just the ideas. At this point we were just throwing ideas around. And then, of course, another key thing was that one thing that I think is really important about cooperative games is that we noticed when we prototyped that if one player has one unique ability, say in this case the long neck, the other player needed something else. And I thought, hey, wouldn't it be cool if you had like a small dinosaur that could headbutt objects and they would kind of flip upside down? That would be really cool. So then, each player had something unique there. And at this point, we're still just throwing these ideas around. And then we would start immediately prototyping. So me and a programmer would sit down and start dividing up the work. Okay, I will do one of the dinos, he would do the other one, and that's it. We were just 2 guys. Now, another really important aspect when doing a game which has like unique gameplay for each and every level of the game was that we really had to constrain the time, meaning time boxing was of the essence. It's very easy when you start from scratch or making a mechanic like this that you would spend weeks and weeks and weeks just doing, exploring what you could do with a long neck dinosaur. But we had to stay really focused and on track to make sure that we didn't end up doing that. So what we would do is just time box on a weekly basis, what we would do. Because we only had a couple of weeks making this whole scene. So the next step would be to start implementing. And given the time boxing, we also realized that we would have to constrain things a lot. We would have to make it very, very simple. If the long neck could walk around and pick up things anywhere and put them anywhere, that would be a huge technical challenge. So instead we decided, okay, moving objects, lock it to a 2D kind of movement. That's something that's very controllable for us developing. It's also very clear and readable for the player to understand what's going on. So we decided we're going to do that. And then we started looking at the other dino, the headbutton dino. And we also realized that, okay, if this dino is going to move around everywhere, that's also going to be a problem. So very early on, because of time constraints, we decided to constrain the other dino onto a 2D movement as well. So now we had like sort of a technical idea of like, okay, this is how we're going to do it. Next challenge was, of course, that, okay, we had so little time. Weren't even able to give the small dino a jump or anything like that. They could just move back and forth on a line. So the headbutting part would be quite difficult to do. So instead we decided, okay, let's do a ground slam instead. And the ground slam would then flip a bunch of objects. Now we're starting to get somewhere. So this was maybe after a week of just coding and putting everything together. We could have like a little level where we could test these things out. But we also realized, we needed some icing on the cake here. Because one extra improvement on cooperative mechanics is to make sure that they really complement each other. So yes, the big dino could move objects and help the little dino to kind of progress, but we added a flair to it where the big dino could then grab certain objects and prevent them from flipping. And this would allow me as a designer to create really interesting puzzles where the big dino could affect the state of that level together with the small dino, and it kind of required discussion between the players. So now that we had all those keys in place and it sounded like a good idea, we started to implement this, and then it was more a matter of creating a small scene, a small level with these mechanics that we had together, and that was from a game designer perspective very standardized. We would start with teaching just moving one platform up with one of the dinosaurs so the other player could get to the second dino. Then the second dino gets the chance to do the headbutt or the ground slam action, and you would see that what was happening, and then step by step we would just increase the difficulty. And then once we had that scene in place and all those mechanics felt like we had a good feeling in our stomachs, this makes sense, we would start to test things. So we would bring this to people outside of the studio to test it, and then we would have a look at how they kind of experienced the whole thing. What were they looking for? Did they understand what we wanted them to do? Did they understand the mechanics? and we realized that, yeah, there was a bunch of things here we needed to highlight. You know, we need to tilt the cameras a little bit, show some hints, show some icons and button presses and stuff like that. But in general, we had a really good feeling. So based on that feedback, and early on, I would like to emphasize that early on, we only looked at what the players understood and not. We didn't really care about what was fun. Then we would move on to think about the context. Okay, so how does the players end up here? The cutscenes, you know, all those things that was going to happen along the way to kind of bring the context and have this scene fit into the grand scheme of things. So if you look at the conclusions, one thing that was really grateful and great was the fact, you know, I could sit next to a programmer and I could work with him. We used the same tools, and that was really efficient. Another really good thing was that, you know, I could sit and have complete ownership of my work all the way from first idea to the finished product. And that was a huge success, I think. And sure, I mean, some systems and whatever, you know, had to be handed over to a programmer because they became too complex. But all in all, I think it was a huge win. And the fact that we had these tools that enabled us to do all this stuff. Now, you might think that, you know, isn't that a big of a risk? You know, you have a level designer who's usually only building levels, and then suddenly you give all these other responsibilities on top. You know, we're talking game design, we talk programming on top of level design. You know, isn't that risky? And I would agree, yes, it is risky. But a game like this kind of required to think a little bit outside the box from a production perspective to even make it happen. And personally, one of my mantras is, you know, if you go to the gym and you pull the same weight every day, you're not gonna reach your full potential. So I think a good step or a good key here was to put everybody a little bit outside of their comfort zone to kind of see them reach their full potential. And then I think also for me as a lead, it was fantastic to see the team kind of jumping on these challenges and how much they grew along the way and how much everybody became better and the ownership they had because they could, you know, actually have so much hands-on experience. And then, of course, another key thing here is the simplification of mechanics that I mentioned, that trying to constrain and simplify the idea as much as you possibly can. It helped out in two ways. One, of course, like I mentioned, was the time. We didn't have much time per mechanic. Another big win, of course, with that, the sort of you don't really think about it, but a secondary win is that simple mechanics are often very easy to communicate. If you only have one button to press, you know, it's going to be very easy to teach that to the players. So I think that was a really nice side product to it all. And with that said, thank you so much for listening. So evaluating the difficulty is only a matter of collecting data from players. So whether that is from a statistical standpoint where you have 10,000s of players, you know, playing through an already finished game, or just sitting and watching, doing a qualitative sort of investigation where you're just sitting behind your subject watching exactly what they're doing or recording on a screen. I think the importance there is to agree on, you know, what is your game gonna be? Is it gonna be difficult or easy? Those words doesn't mean the same thing to everyone in the team. So you need to make sure, first of all, that everybody agrees on what easy means, if it's easy you're going for. And then kind of, it's actually a good thing to set up a few criteria as well. So like, if it's a game where you fall down and die, okay, if we don't want it to be easy, maybe the player shouldn't die more than a maximum twice on the same challenge. So you set up a little bit of parameters, and once you've kind of agreed on that as a group, it's much more easy to do that evaluation, because then you have, you know, a player that you're recording or watching. What are they doing? You know, is there a challenge where the same player dies over and over and over again? You have to take a step back. Does that mean that all players are doing the same thing, or just that one player? And if it's just that one player, is that really your target audience? And you have to ask yourselves that. So there's a couple of steps you need to make. And This is a little bit different if we're talking about puzzles, challenges that are not about, winning or failing. It could be a puzzle where you need to figure something out, more of a mind game. And if that's the type of game you're doing, I think it's also good to keep in mind, how long do you allow the player to be stuck and thinking before you feel, now too much time has passed, this is a too difficult challenge for the players. So I think, to summarize, you need to set up some sort of rules and a framework for how you evaluate difficulty, and make sure that everyone agrees on those parameters, because that makes it much more easy for you as a developer to go into playtesting with confidence and look at, did you hit your targets or not, and what can you do to make all the challenges or puzzles or whatever it is to kind of fit the target you're going for. The absolute key for designing a successful co-op game kind of comes with the word cooperation or collaboration. I think it's incredibly important that the players, they need to have abilities, or there needs to be a space for the players to collaborate and give them tools that require them to work together. So whether that is you have a nail and I have a hammer, and you have to hold up the nail and I have to hammer it. I mean, it could be that easy, but having the game encouraging and sometimes even enforcing us as players to work together to achieve a certain goal, I think that's incredibly important. Another thing to even step it up a notch is to make sure that those abilities require some timing. It's not like I can place the nail and walk away and then you come 10 minutes later and smash it with your hammer, but rather make sure that both players are there at the same time, forcing them to communicate about how to nail that nail into the coffin.